Assalamualaikum and hello everyone. My name is Nurul Najiha binti Nur Haizun. My student ID number is 2023867936.
Assalamualaikum and hi everyone. My name is Sharifah Sofia binti Syed Saludin. My matric number is 2023865946.
Hi, Assalamualaikum. My name is Azwa Safrina binti Rumi Husaini and my matrix number is 2023868284.
Hello and Assalamualaikum. My name is Nur Ainin Sofia binti Shah Nizam and my matric number is 2023872878.
The objective of this experiment are: number 1, to determine the volume and density of ball bearing, and number 2, to determine the volume and density of glass block. Introduction or theory of this experiment is: the vernier caliper is an instrument that can measure external thickness, internal diameters, and depth holes to a maximum of 130 mm with a 0.05 mm approximation. This instrument have a main scale and sliding scale that allows reading the object to the nearest 0.02 mm. Plus, vernier caliper also can be found in the laboratory. The vernier caliper can be used by measuring outer dimensions of objects by using the main jaws. To measure the inside dimensions, the smaller jaw at the top will be used, while the stem is used to measure depths. Besides, for measuring outer dimensions, the object should be placed between the jaws, which are then moved together until the object is secure. Each measurement will be precise and accurate if it takes several times, and then compute the arithmetic mean of the values. While the micrometer screw gauge is used to measure even smaller dimensions than the vernier calipers. This instrument uses an auxiliary scale to measure hundredths of a millimeter, which is marked on a rotary thimble. This screw have an accurately constant pitch, which is the amount of the thimble moved forward or backward for one complete revolution. Besides, the jaws can be adjusted by rotating the thimble using the small ratchet knob. The jaws must be opened by 1 mm, which requires turning through 2 revolutions of the thimble. To measure an object, the object must be placed between the jaws and the thimble is rotated using the ratchet until the object is secure. Furthermore, the lock at the instrument may be used to ensure that the thimble does not rotate while taking the reading.
Now let's see the apparatus that we used in this experiment. Apparatus for the first procedure is micrometer screw gauge, weighing scale, and ball bearing. For the next procedure is vernier caliper, weighing scale, and glass block. Now let's move on to the procedure. Procedure A is for micrometer screw gauge. Firstly, the zero error was determined. Second, the diameter of the ball bearing was measured. Next, step 2 was repeated at least 3 times at different positions of ball bearing. 4. All data was recorded in a suitable table. 5. The actual diameter reading was calculated by taking into consideration the zero error obtained yearly. 6. The weight of ball bearing was determined, and the last one is the density of the ball bearing was calculated. Now let's see procedure B. Procedure B is for vernier caliper. Firstly, the whole number of small divisions on the fixed part of the caliper that are to the left of the zero marks was counted on the vernier. The size of the object to the nearest number of whole millimeters was given. Second, the first mark on the vernier that line up with one of the marks on the fixed part of the caliper was found. The value of the mark on the vernier then told how many fraction of a millimeters were needed to complete the estimate of the size of the object. Next, the zero error of the vernier caliper was determined. Number 4, the length, width and thickness of the glass block was measured by using the vernier caliper. 5. Step 2 was repeated at least 3 times at different positions of the glass block. 6. All the data was recorded in a suitable table. Next, the actual measurement was calculated by taking into consideration the zero error obtained early. 8. The weight of the glass block was determined, and the last one is the density of the glass block was calculated.
Now, let's take a look at the result. Here are the results and the data that we collect from the experiment. For the analysis, first we have to calculate the volume and the eccentricities of ball bearing and the glass block. We use the formula volume is equal to length multiplied by width and multiplied with height. As a result, we have volume is equal to 3.618 times 10 or the power of negative 6, and the eccentricity is 1 times 10 the power of negative 5. For the glass block, the volume is equal to 1.173 times 10 the power of negative 6, and the eccentricity is 8.34 times 10 the power of negative 9. Second, we have to calculate the density and the eccentricities of the ball bearing and the glass block. We use density is equal to mass over volume. For the ball bearing, we got density is equal to 7,739.1 kilogram meter the power of negative 3. And the eccentricity is 2.42 times 10 the power of 4. And for the glass block, the density is 2.47 times 10 the power of 5, and the eccentricity is 1.03 times 10 the power of 4.
Let's move on to the discussion part, which is in this experiment, micrometer, screw gauge, and vernier caliper have been used to measure the diameter of a ball bearing and to measure the length, width, and height of a glass block respectively. Micrometer screw gauge is an apparatus used for measuring accurately the diameter of a thin wire or the thickness of a sheet of metal. The screw has a known pitch such as 0.5 mm. Pitch of a screw is the distance moved by the spindle per revolution. Hence, in this case, for one revolution of the screw, the spindle moves forwards or backwards 0.5 mm. This movement of the spindle is shown on the engraved linear millimeter scale on the sleeve. On the thimble, there is a circular scale which is divided into 50 or 100 equal parts. Therefore, the micrometer screw gauge has a sensitivity of 0.01 mm. Alright, so this is how we calculate the sensitivity of a micrometer screw gauge, which is pitch is divided by number of divisions on the circular scale. Okay, that it can be 0.5 divided by 50 and we get 0.01 mm. So 0.01 mm is the sensitivity of a micrometer screw gauge. In the other hand, vernier caliper is used to measure the diameter or thickness accurately. It has a sensitivity of 0.01 cm. For example, the value of the smallest division on main scale is divided by total number of divisions on vernier scale. To determine the diameter of a ball bearing, a micrometer screw gauge was used because it is more sensitive in measuring small objects compared to vernier caliper. By applying the formula V equals to 4/3 pi r cubed, we have found that the volume of average ball bearing after the true readings have been obtained. which is true reading equals to observed reading minus 2 zero error, is V equals to 3.618 times 10 to the power of negative 6 plus minus 1 times 10 to the power of negative 5 m cubed. The zero error occurred in this experiment is 0.01 millimeter. A zero error results when the zero mark of the scale does not match with pointer. The zero error axis may be due to instrument error and also parallax error. To determine the length, width, and height of a glass block, a vernier caliper is used. By applying the formula V equals to length times width times height, the volume of average glass block after the true readings have been obtained is V equals to 1.173 times 10 to the power of negative 6 meter cubed. No zero error occurred on the vernier caliper. The density of the ball bearing and glass block were calculated using the formula density equals to mass over volume. By using a mechanical balance, the mass of ball bearing and glass block were determined. The mass of ball bearing is 27.76 gram, while the mass of glass block is 289.71 gram. To get the density of both materials, the mass is divided over the volume of average true reading. The density for ball bearing is 7.739 times 10 to the power of 3 kg meter cube, while density for the glass block is 2.47 times 10 to the power of 5 kg meter cube.
Now, we're at the last part, that is conclusion. For this experiment, the objective to determine the volume and density of ball bearing and glass block were achieved. The apparatus that we use are very suitable to obtain an accurate result for the diameter of the ball bearing and the length, width, and height of the glass block. To calculate the density of these two objects, we use the formula density equal mass divided by volume. We only determine the mass from weighing the objects by using the weighing scale. Next, we calculate the volume of these two objects by using a suitable formula. For the ball bearing, we use the formula V equals 4 divided by 3 by R square. Whereas, for the glass block, we use V equal to L, which is length, H, height, and W is width as the formula. During the experiment, we recorded all the important results to the table provided in the lab manual. So, from the data in the table, we were able to count the volume of each object. We also determined the zero error of each apparatus during this experiment period. Lastly, after we obtain the volume, we have to determine the density according to the objective. At the end, we also count the uncertainty of these objects by the standard deviation formula given from the lab manual.